because this looks like a pack talk.
So my wife, I think, is still coming. So what I'm going to do when she walks in is I'm going to say, honey, all of these men have volunteered to have you sit next to them. That won't be, he's patting it. He's patting his lap. What the hell? That's right, I'm a bad husband, apparently. So right now I'm just killing time, waiting to get started. Are we being recorded? Is everybody in? Very, very cool. So we'll give it a few more minutes. We got some people coming in. People in the back, please feel free. We still got some hands up. Hold them up high. You don't want to stand through this presentation. It's going to be long. And there's going to be math. Not from me. God, no. Not from me. I'm the dumbest person at my company. Also, we have some children coming in. Please make room so the entire family. If you guys could kind of pull towards the outside edges so we can get the kids in. So if you have a seat next to you, scoot outwards so we can get a seat of 3 for a family. Think of the children. Won't somebody think of the children? So, like, for example, come up front. Come up front. Come up front. We got you right here. You guys right here, all of you, scoot that way. All right, there we go. There we go. And these 2 girls can, there we go. See? Everybody, a round of applause. See? And that's operating system theory. That's how we do memory management. Children, you just learned DL Malik. All right, so let's get this started. First and foremost, I want to say thank you very much for attending this presentation and proving me wrong. I greatly appreciate that. If you guys remember, a number of years ago, I came up here and I said, if we did a talk on defense, no one would show up. But if I was giving a talk on hacking a toaster, everyone would show up. And having a bunch of people show up, oh God, am I in the right room? Is this the break it room? Because I really want to go in that room. But we're going to be talking about defense here a little bit. So this is an introduction to the RITA framework. A lot of you will ask, why exactly do we call it the RITA framework? Because John's mom was taken. That's what we were going to call it. It's named after my mom. And I didn't name it after my mom. The fine folks at BHIS did. So we're going to go hunting for bad guys for free and using math, using hunt teaming tactics. I'm going to do the introduction and get off the stage as quickly as possible and pass it over to Joff from Security Weekly. We're going to give Brian, he's going to jump up. Where's Brian? Okay. I was starting to get nervous because I haven't seen you yet today. And it's probably because we wore the same shirt. I'm like, yeah. All right. And testing and validation, Derek's going to come up, and then I'm going to give some conclusions. But before we get into that, some things that I like to bring up in many presentations is I'd like to cover why it is that current defensive security technologies are not working. A lot of presentations you attend, they will talk about how everything is broken, security is broken, vendors are dumb. Look, vendors are vendors, right? I spent a good portion of yesterday trolling Symantec because they're right across the hall from us by running a video on how to bypass Symantec antivirus at our table. And Symantec, they basically said, well, why don't you try our next super awesome generation tool for advanced threats, whatever they've changed the name of that product to like the 3rd or 4th time. And I said, we'd be happy to bypass it as soon as we've seen a customer implement it successfully. That's a little bit of escalation, right? But it's not their fault, okay? It really isn't. As much as I'm making fun of those fine gentlemen that are at the Symantec booth, they do the absolute best they can. But the fact is, if we're taking a look at what we've been doing in information security, we're doing the exact same things. I've opened with this slide at 2 Derbycons so far. We're doing the same thing for the past 5-6 years. We're seeing the exact same bad pattern because we're doing the same thing again and again and again, and we're expecting different results. So with that, I have a couple of questions for you. First and foremost, name 3 AV companies, big ones. You have a cheat sheet up here. Symantec. Okay, well that's cheating too. I just got done talking about them. That's awesome. Symantec, Kaspersky, Sophos. No one's mentioned McAfee. Are they so bad they don't even qualify now? So name 3 firewall IDS vendors. Big names. Palo Alto, Checkpoint. Cisco, we're done. All right? Now, whenever we're looking at that, what is the total market share? Whenever we look at Symantec and McAfee, when we look at Palo Alto, we look at Checkpoint, we look at Cisco, we're looking at well over 80% of the total market share, right? These are massive, massive companies with a massive market share, and almost all of us have their products implemented in their environments. So name a couple of adversaries. Are you afraid of China? Are you afraid of Russia? Are you afraid of the NSA? Are you afraid of organized crime? Now, I had Pinky in the Brain up here. I saw someone wearing a Pinky in the Brain shirt yesterday. And how did they start every single episode? Brain, what are we going to do tonight? Everyone? Same thing we do every night. Try to take over the world. Now, Erica pointed out to me when I showed her this slide, she goes, you could have used Vladimir Putin for organized crime and Russia. But to be perfectly honest, he terrifies me a lot, a tremendous amount. So this is the leader of Russia, and by all intents and purposes, according to polling, it looks like we're going to get Donald Trump. It's a hell of a comparison between those two. And I haven't ever seen Donald Trump without his shirt, and now you have that image in your head, so you're welcome. So one last question for absolutely everybody. Do you think the adversaries that we listed on the previous slide have the ability to bypass the limited technologies that I just mentioned? Yes, they're static. Your defenses are static. Black Hills Information Security, predominantly we do network penetration testing. Isn't it odd that the main products we release are Active Defense, Harbinger Distribution, the RITA framework for hunt teaming? Because we desperately want to see the world become a better place. We're trying to create products and release products that make things difficult for us. Because defenses are static, and static defenses are easily bypassed. Because all the bad guys have got to do is simply get them in their lab, bypass them in their lab, and then bypass them on your network. In short, breaking into your networks is many times a foregone conclusion before they launch a single packet at you. So this requires us to be active. This requires us to stay away from the easy button, because every time you hit the easy button, what does God do? No, he doesn't kill a kitten. That's something completely different. You're mixing your memes. Every time you hit the easy button, God deploys another bot on your network. We got to stay away from the easy button. So hunt teaming is actively looking for advanced attackers in your network. If BHIS can bypass IDS, IPS, AV, attackers can too. We're a small company out of the Black Hills of South Dakota. So we're going to be talking about looking for beaconing activity. It involves close coordination with our customers, for consultants. It requires close coordination with our internal teams, because we have to ask questions, because we have to analyze our networks. Dang it, isn't that what being a hacker was all about initially? It was about knowing things, understanding things. And right now, we don't understand things. Instead, we're constantly looking for a product. We're constantly looking for an easy way out. We're trying to make things as simplistic as we possibly can. I have a number of customers, because hunt teaming is such a hot topic, they come up to me and they say, what's the major product in the hunt teaming space today that we can buy and will make hunt teaming automated for us? In short, this is not hunt teaming, folks. Going out and buying a product off the shelf and then calling it hunt teaming is completely anathema to the entire idea of what hunt teaming actually is. So, how do we approach it? Well, this is the beginning of a framework. We're not trying to release a tool and telling you we can catch absolutely everything. If anyone stands up like, I can create a piece of malware that'll bypass that, great, write a signature for it. Write a new plugin that'll do a statistical analysis to identify it. Let's try to get better. Actually, I take the signature thing back. We aren't going to talk about signatures. We're talking about statistical analysis and other things. So with that, I'm going to hand it over to Joff, who's going to come up and he's going to talk about DNS logs. Then we're going to do Brian, and then Derek, and then I'm going to come up and wrap it up at the end. So Joff, take it away. Joff from Security Weekly, everybody.
Right. Wow, what a crowd. All right, so good morning. What's that? Yeah. Oh, you're not. Right. How do I follow that guy? All right, first of all, isn't Derbycon great? Come on, let's hear it for Derbycon. Yeah. All right. I'm just trying to warm up. So now that I have to follow John. By the way, I did walk in and I saw our booth when I first got here, and I was like, geez, John, is that my video? Right across from Semantic. So anyway, that was fun. All right. So I get to talk about the dry stuff. So a little bit of math. C2 hunting using DNS logs for starters. So, you know, we floated around a lot of concepts. Statistical analysis, the math behind what we wanted to do, to achieve some of the goals, and we looked at lots of different sources of information. And DNS logs is a really incredibly valuable source of information on your network. What can we do with it? Well, what we decided pretty early on is take a fairly simplistic approach. Let's look at DNS servers that are facing the client side of the network. Let's look at them from the perspective of getting log information and performing a peer statistical analysis on all the data that's coming out of the logs and compare what the individual stations are doing to each other. Okay? So the idea here is we tally all that information up and we just do means and standard deviations and we look for things that are outliers. Fairly simple concept. And to do that, we're just asking our customers just to turn on debug logging from the Windows domain perspective, or if they're running a bind9 environment, we'll look at turning on bind9 logging and ingest those logs into our code. Whether it's Python scripts or whether it's Elasticsearch, we're just pulling those logs in, calculating the tallies, doing the mean standard deviations, and pulling out the outliers. Okay? So we subtotal by response code, we subtotal by query and response types, we create those mean and standard deviations, we look for standard deviations outside, two outside the mean, and if we see them, we'll then just point them out. This one is an example of just the Python script. One of the challenges we run into when we're doing this is that we have to filter certain nodes on a network in terms of what their behavior is. For example, we might pick up a mail server in the data set from the DNS debugging logs. Mail servers are going to have lots of MX queries, perhaps some service record queries, maybe some TXT queries. They're going to stand out immediately as two standard deviations away from the rest of the traffic. So we have to play with the code so that we're filtering that stuff out so that we don't pick up things that we don't want to peer compare. So there are some challenges there. But we can filter that stuff out intelligently. If we go to a customer and say, look, what's your mail server? What's your domain controller address space? Let's filter that out. Let's just look at your client workstations and get those outliers. Make sense? So from a visualization perspective, what we do is pull that data in, we run the means and standard deviation, and then we take the output of that and we write it back into a field in Elasticsearch. And the field is a behavior field. If there is a two standard deviation outlier, we tag it, and we tag it as a potential DNS behavior, essentially. But we don't have to look at it from that perspective. We can also look at the raw data inside of Elasticsearch using the Kibana visualization piece in the elk stack. And just looking at the raw data, the example on the screen is raw data where we are running DNS cat, right? So what's a behavior of DNS cat? Anybody know? Lots of queries, but of a certain type, right? TXT record types. So if you run that, even for a shorter time period as maybe 5 or 10 minutes, you're immediately going to see a massive, massive increase in the amount of TXT DNS queries coming from a specific station, right? If we visualize that inside of Kibana and Elasticsearch, and we actually just do basic histograms, we're going to see some big deviation. And that's before we even run the mean and standard deviation analysis, okay? After we run the analysis, we can cut the data in different ways. So this is just a pie chart, or several pie charts. After running the analysis of having the behavior flagged inside of Elasticsearch, and then just plotting the different IPs that have that flag turned on. It's just a binary flag, so you see the counts are really low, right? But we can see that in this case, we had one address that had 3 different record types that got flagged. And the unusual thing here is a TXT record type. Again, it was that DNS cat behavior, okay? That was the outlier and got flagged in the data. So this is actually doing visualization on the results of the statistical analysis rather than just the raw data, okay? So you have 2 choices there. So another thing we can do with DNS data is look at domain generation algorithms, okay? Domain name generation algorithms. Now this is when we get into more of an AI approach. With domain name generation algorithms, what I went after is, what if I can train a model, a random decision tree essentially, that enables me to identify a domain name that's highly randomized. Identify a domain name that is being looked up that is likely botnet related, okay? So what I did is I went out and grabbed 10,000 DNS lookups from OpenDNS that are good lookups. I grabbed the top 10,000 that were random domain names from the good lookup pile, okay? Then I grabbed the top 1 million Alexa, good domain stuff from the URL perspective, all right? Then we grabbed some bad data, In this case, the DNS lookup list from CryptoLocker and Game Over Zeus botnets, right? Highly randomized DNS lookups straight out of the algorithms that generated these domain names that were specifically used for fluxing activity with these botnets. And then we grab some good English words as well as that, okay? Grab all those things, and then we have to develop what's called classifiers in the DNS DGA hunt teaming feature. To do classifiers, we have to look at different measures in the data. In this particular case, and this is based off some work that's out there widely published, it was click security, length and entropy are two good measures. N-grams, being the repeated occurrences in a domain name, in the 3, 4, 5 space tend to be very good, and then some differences between the n-gram distances. We take that, we measure it across all those data sets, and we feed it into a random decision tree. So this is a classic AI algorithm, okay? Once we feed it into the random decision tree and have it calculate all that stats and build the trees, build the forest essentially, we're then going to serialize that trained data to disk, and we've built kind of a brain, a way of thinking, okay? We can do different feature sets. We can decide to look at the number of consonants in the DNS lookup. Maybe we can look at the ratio of numbers to letters. We can have different features that we can use. But either way, we're going to build a brain that is biased in certain directions depending on the data that we're looking at. Okay. So then what we did here was a Python script that initially just does the classification and training of the model to disk. And then we look at the raw DNS data and do some testing off of that. Test against the bad domains, pull as many different data sets for testing as we can to try to get the quality and the precision of that brain as close as possible to giving us real data, okay? Other feature sets, like I mentioned, we can experiment with. So that's really about it. I'm going to turn it over to Brian. I know it was very short, but I've got like 6.6 minutes. But we will be here for questions afterwards. Thanks, John. And we're going to have Brian explain some deep-level math that he developed for the framework. So come on up, Brian.
All right. It's 2 tough acts to follow, but let's go for it. All right, so I'm going to talk more about beaconing, not to be confused with baconing. Sweet, sweet bacon. All right. So beaconing. A lot of malware that we're seeing, a lot of C2 channels, usually this malware is going to try and it's going to call home. It's going to say, hey, I'm still here, I'm still here, I'm still here. And so when these calls happen, they're usually going to happen at predefined intervals. It's going to happen, the time between each beacon is going to be roughly the same, usually is what we're seeing right now with most malware. And so let's bring on this math, all right? All right. I appreciate that people got that. Thank you. So when we look at network connections, we were looking at this log data. It's really just time-varying signals. Anyone who's into signal processing, you'll look at this and you'll say, yeah, it's just a signal. There's nothing special about it. We can take that and we can apply most of the fundamentals of signal processing. And so when we're in signal processing, we typically have 2 domains. We have what's called the time domain. So we're looking at things occurring over a series of time, saying like this occurred at this time, this next connection occurred at this next time, and we spread that out. And so we have a time and we have an amplitude. All right. So the other domain that we look at is called the frequency domain. We're looking at what frequency are those connections happening? What frequency is most dominant in the signal that we're looking at? And so how can we determine the frequency? If we have a time signal, we have something occurring in time space, in the time domain, how can we tell what frequency that's occurring at? Well, we have what's called the fast Fourier transform. It's technically the discrete Fourier transform, but we won't go too much into that here. And really all this does is it just transforms the signal from the time space, or the spatial domain, to the frequency domain, so that we can look at that data in a little bit different way. And so what? What does this mean? All right. Well, most users, if you look at most user activity, it's not going to be a predefined interval. I'm not going to click on a link every 5 seconds. I'm not going to view an image every 10 seconds. It's not going to happen. There's going to be some variation. There's going to be some randomness in the way that I'm browsing around. And so most software, though, is not going to occur randomly, especially malware. That's what we're seeing with most of the major malwares that's out there. Interpreter, DNS Cat, all those things, which Derek will talk about a little bit later. But all these are really occurring at regular intervals. And this is something that sticks out quite a bit. If we take those connections and we look at that within the frequency domain, we can quickly spot that. And I'll show you that here. So here's just some data that I generated. This isn't actual log data, but this is just kind of more of the fundamentals of how this process works. So on the top, we have a signal that's in the time domain. You can see on the x-axis there, we have time in seconds. Y-axis is just amplitude of the signal, just a basic sine wave. I mean, you can look at that and you can say, yeah, okay, that's occurring at a particular frequency. But let's see what frequency is that occurring at. So after taking that signal, running that through the fast Fourier transform, we get down on the bottom the frequency domain of that, the frequency domain graph. And there we have a large spike that's at about 5 hertz. That means it's occurring 5 times per second is roughly the frequency of that transmission. Okay, cool. So let's look at something that's a little bit faster. Okay, so we can look at that. It looks like it's occurring at a particular frequency, but what frequency? Okay, so here we can see this one's occurring at about 100 hertz. That means 100 times per second these transmissions are occurring. All right, so let's make it a little more interesting. What about if we add some noise? So say there's some jitter. So this might be something more of what you're going to see. We have this signal. Now we're looking at this one on the left. We can see, we're looking at it. Is that predefined frequency? Is that occurring regular intervals? I don't know. But let's throw it through the Fourier transform. And on the bottom, we can clearly see there's still that spike. So all I've done there is I took that previous signal that was occurring every 100 hertz, threw in some noise, we run it through the Fourier transform, boom, it's still there. It knows exactly that there is a dominant frequency in that signal. And so if we compare that to the right graph, all that is just random noise. I've just created a random signal that might be a little bit closer to what user behavior is going to be, and you can see we don't have any large spikes. We don't have any huge spikes that stick out and say, hey, this is occurring at exactly this frequency. It's more static, it's more noise. And so that's one way that we can kind of distinguish malware behavior from normal user behavior. So if we're looking through logs, we're throwing this connection data through these transforms, we're going through and we see something like what you see on the left there, we're like, hey, that's interesting. We should go look at that. We should find out, do we expect that software to be there? Or is that something kind of unexpected that's popped up? And so with that, I'm going to go ahead and I'm going to pass this over to Derek, who's going to talk about the actual results that we've got for different malware samples.
Hello, everyone. So you might be wondering, does all this mathiness really work? So what we did was we set up a virtual testing environment. We set up a FreeBSD router and used Ubuntu to capture the data using Bro. If anyone knows me and talks to me, I am an unapologetic Bro fanboy, so I had to use Bro to log this. And then the infected Windows 7 machine was routed to go through the BSD router as the default route, and the FreeBSD router had a bridged connection over using VirtualBox's IntNet feature to log on one of the interfaces on the Bro machine. And then we wrote a Python script to simulate random traffic because, obviously there's not a whole lot of users in this environment, so we wanted to make sure that there was some randomness in the log files. So we started with PowerShell Empire. I don't know if you've used PowerShell Empire. It is a great framework. The default way that you can create C2 and PowerShell Empire is through HTTP. And if you look at a log file, it's fairly obvious how it's communicating. The default is a 5-second interval. You can configure jitter. We did not configure jitter for this. And if you look at the graph, there's a max peak of 0.18, and then some more digits after that. And on the bottom, you can see that it's probably a little difficult to see, but in the log files, every 5 seconds, it's beaconing out to the IP address that we had set up for command and control. The max peak works out to be, if you do the math, every 5.3 seconds. So it matched up. Next, we use custom malware that we have at Oculus called VS Agent. This uses HTTP view state to communicate. So again, we set it up and let Bro do the logging. We discovered that there was a max peak value of 0.098. And so that worked out to be every 10 seconds. And if you look in the log files, it matched. Every 10 seconds, it was calling back home for the communication. Next, Meterpreter. Everybody uses Meterpreter, right? We set it up to be encrypted, HTTPS, using the reverse HTTPS module. And in the log files, we saw that it was basically every 10 seconds. And again, the max peak value of the Fourier transform matched the actual beaconing traffic. And then, Joff talking earlier about DNSCat, we had to use DNSCat as well to test. Here is actually a little bit different. DNSCat communicates every 1 second. And I actually did not know this until we actually started looking at the log files. I had no idea how much traffic was involved with DNSCat. So here the max peak value doesn't match. However, you can see the same peaks and valleys. There's a strong signal there that beaconing is occurring. The reason it doesn't match is some more mathiness. It's the Nyquist frequency. It's because the traffic is every 1 second. The fast Fourier transform, because the minimum time is 1 second in the series, it can't pick up that traffic. However, you still see that there are strong peaks and valleys. Obviously, beaconing is occurring. And now it's John's turn again.
Okay, so the single biggest thing that I would like everybody to take from this is we are not up here saying, hey, we're going to catch all malware. That's not the point. What we are saying is, hey, how about we create a framework where we can actually do some statistical analysis to help us identify more advanced malware. And I think that that's a key difference. And as part of it being a framework, it means that we have different things that are going to come up all the time. For example, do we have Lisa and Joe here? Lisa and Joe. There we go. Stand up. There are also two of the developers on this project, so give them a round of applause as well. So last week, I got pulled into the office, and Lisa sat me down. She goes, we've got a problem, or we had a problem. And the problem was, if you have something that has a strong beacon, and then that system goes offline for 6 hours, and then it comes back on, it blows the statistical analysis away. And fast Fourier transform would run into issues in actually identifying it as an outlier at that point. So Joe and her wrote a new algorithm that would help identify those particular cases, right? You also have randomized data, like if something tries to be randomized in its beaconing, how do we actually go about detecting that? You also have EVTX event logs that you can parse and you can import into the system, and it'll look for multiple concurrent logins. It has nothing to do with beaconing on the inside, but don't you think it would be useful if you're doing incident response, if you could pull a list of every single account that is concurrently logged into multiple systems at the same time? Hell yeah. Okay, that's in here. Also, bad domains. We're shocked at how many organizations we go into and we run that and just say, okay, how many systems on the inside are going to known bad actor domains? A lot, apparently. And that was kind of shocking when that occurred. So what you should take from all of this is what we're giving you is effectively a prism. And we're inviting everybody to come and help us with that prism. Okay, we're all going to work together on this prism. And if you know what the prism, you turn it, and it displays different light, right? It's all the same light, but then it breaks it up into different frequencies, and you get different colors, and you get different views. So we're not trying to develop a framework that basically says, hey, this is pure evil, and it generates an alert. That's not what we're after. What we're trying to do is create tools that require us to interact with the data and giving us the ability to do so effectively, all right? Now, I strongly believe that we aren't going to see very many products in the space that are going to be very good at this, and I want to explain why, at least not right away, all right? I don't think that we're going to see a lot of products in this space that are going to do fantastic anytime real soon. And the reason why I don't believe that we're going to get into this anytime real soon is because of the tremendous amount of false positives that you get, okay? So let's go through some sample false positives, some data that we've seen. If you have an anti-spam appliance, and it's checking domains constantly to see if those domains are evil for the spam coming in, do you think that that's going to generate a frequency that it's going to known bad domains on a very regular basis? Oh, hell yeah. Okay, here's another fun question. Skype IP addresses, where Skype connects back and then makes connections so you can do Skyping. Do those stay static? No, they tend to move around. Do the ports stay static all the time? No, they tend to move around. So you see situations where Skype is generating frequency. You see situations where Box.com traffic or Dropbox is generating this type of frequency. We've even seen organizations, for whatever reason, they've decided to put a syslog server out on Amazon instead of the inside of their network, and they have systems regularly sending logs out to the Amazon EC2 cloud. And you're like, well, why are you doing that? Like, we don't know. So that looks like beaconing. So the point of all of this is, if somebody was going to try to create a commercial product that just kicked out a report nicely and at the end of the day said, you have been hacked, it's not going to happen. Because there's so much noise in your environment that looks like malware, except that's not really the right way to look at it now, is it? More accurately is your malware is beginning to look like the noise in your network. And we need better tools to actually start filtering and doing analysis on that. So like I said, this is absolutely an invitation for absolutely everyone in this room to, if you want to get involved, or you want to write something in Python and you want to submit it so we can do a different type of analysis, thank you. That's awesome. Somebody wants to take a file parser to parse a specific weird type of firewall or some type of DNS that we haven't encountered yet. Thank you. That's awesome. So we're basically creating a framework. We're inviting everyone to come and play in that framework, and then, of course, we can use it as well. And this gets into a bigger problem of computer security. At least I'm hoping that this helps make things better. Because seriously, what did you guys think security was going to be? And this matters because we have children in the audience, right? And the kids are like, should I get into computer security? Is computer security awesome? Is it like Derbycon? Is it... Okay, so hacking with two people on the same keyboard. Have you guys ever tried that? That's really hard. So I was talking about this, and Lawrence, who's going to come up here in a couple of seconds, said, he has a theory that in Hollywood, all the scriptwriters are trying to come up with the most insane thing possible that'll actually make it all the way through, making it onto a TV show or a movie. This guy must have won something, whoever wrote this scene. Lawrence's quote, I love it. He goes, he has to know how keyboards work. He wrote a script. So, this is what we think computer security is like, right? And you walk by some of the booths that are out there, and they're like, become a cyber warrior, become a cyber defender. And the fact of the matter is, this isn't what computer security is like. More accurately, what computer security is like is a computer breaks or it gets compromised, and then you clean up the mess, right? You constantly get notification. Clean up on aisle 3. Bill Smith's computer has CryptoLocker. And I love the dog. I'm so glad you're home because someone pooped in the hallway. How many of you, when you get back to work on Monday, you fully expect someone to come up to you and ask something analogous to that? Dude, how was Derbycon? It was good. Bill Smith pooped in the hallway. You mean his system was compromised? No. Literal poop. So this is what computer security is, right? It's cleaning up after things. And it's not being a cyber warrior, right? We're not running around fighting hackers yet. But you know what? We might be able to hunt for them. And this is at least interesting. And this is what we're trying to do. We're trying desperately to make things somewhat better. Now, Lawrence, I think you have a link for me. So, as I said, here's the deal. The RITA framework that we're releasing is going to be a Git repository. It's going to have a couple of things that you need to have. And Lawrence, if you want to tell them about this while I type this in. Oh my God, this is a long one. Why do we? Is it just to here, or do I have to?
Yeah, I was just it's caps.
Okay.
All right. So
You gotta speak
we're
into the mic.
gonna put this up on Git for you guys today. This is meant to be downloaded, played with, added to. You can add modules. So the short story is Sometime last week, John said, you know, it'd be really cool is if this had a front end. So I got together with Joe and Lisa and Catherine McMillan, who works at Black Hills InfoSec, and we wrote a front end over the past week. And
It's not bad. It's actually pretty good. I'm pretty impressed with it.
It's modularized. So if you were to write your own script and you thought that it might be cool to have in there, there's about 8 lines that you need to put at the top of your module. The front end will automatically detect it and load it. So it's something that everybody can add to, and as John said, that's something that we want to encourage. Add to it. The email address that's there actually goes to the developers, and we will be reading the email. So, you know, aside from hate mail, go ahead and talk to us about what you want to see and whatnot. And note that there will be a README there. There is some dependencies here. The tools that we use at Black Hills InfoSec tend to be like Elasticsearch, Logstash, Kibana. We wrote most of this in a Debian environment, so it's probably going to be easiest to set up there. And I'll be around at the booth today if you guys have any questions.
And by the way, Lawrence is the official herder of cats on this project. So round of applause for him for making this happen. So I would like the team to come up here, and I would like to field questions, and I will play Donahue. So I'm going to walk around. I'm going to hear the question. Do we have a wireless mic that I can use at all? All right. Since we don't have a wireless mic, I want the team to come up, and you guys just raise your hand, and I'll come and hear your question, and then I'll yell it for everybody, or you can just shout it out. So I'd like to open it up for questions, and so first one, let's get started. Come on up, guys. You, sir, in the back, without a mic. Let me repeat the question. So the question is, right now we're specifically focusing on areas like, well, there's some other things that we have, like doing URL analysis for web proxy logs, connection logs on routers and firewalls, and then also DNS logs. We focused on those 3 areas predominantly because they're everywhere. They are the bottlenecks. But you also said you could also write plugins specifically for APIs and custom applications to do the same type of analysis on those applications. Is that a correct reinterpretation of your question? So you don't have good DNS logs, but you do have connection logs for other apps. Is that correct? All right, I'm going to give this one to Brian because it's about ingest, because once we get into the format, we can do analysis on it. So I'll give that to you.
Yeah, so that's something we're constantly working on as well, dealing with different log formats. One of the tools that we have in place for this Python version of the framework is using Logstash. So if you're not familiar with Logstash, it makes it pretty easy to write a custom parser for different log formats. So basically what you need to do is you just need to take your log format that you have. You need to look at the different fields that you have. So see, where you have source IP, where you have a destination IP, destination port, and write a custom filter in Logstash. So it'll go ahead and it'll pull that information out and it'll put it into Elasticsearch. So if you look through the code that we have, you'll see kind of how we're naming fields. What we expect, like what data we expect for the different analysis modules. As soon as you write a Logstash filter and you get that into the Elasticsearch database, then it doesn't really matter to the analysis. As long as it has the different data that it needs, it doesn't care as much about the log format, the log source, rather.
I'm bad guys, and I know that you guys have data that can't be seen in the
Yeah. That's one of the things we were just talking about. That's why we need more filters. So the point was, let's say I'm a bad guy, and I know that it's you have trouble looking at your Fourier transform if it's beaconing at a second or less. Geez, that's really fast. So yeah, that absolutely. That's why we can write additional filters. I'll also pass it over to the guys and can answer that. But that's one of the things that Lisa and Joe were working on.
Yeah, and so I want to clarify that a little bit too. So it's not that it can't detect it if it's going too fast. It's that it's not going to show it at the right frequency. So if you saw in the graph here, let me pull that back up. Is it this one? Yeah, this one. You can see that we actually still did. Sorry. You can see that we still detected it. Just the issue is that the peak, where it says the frequency that it's occurring isn't actually at the true frequency, but it's still there. We still detected that it's happening. And so, but the next question is probably going to be, all right, so I mentioned we're going to have difficulty with random behavior. What do we do there? So that's something else we're working on. We have a couple proof of concepts, something that Joe and Lisa are working on as well too, which I think works really good. So the thing is that we do browse randomly. It's not predefined intervals, but we don't browse 100% randomly. So if you're saying that your beacon should come out using like a random number generator, if we take that, we take the time in between each of the numbers, we look at that over a long enough period of time, and we build a histogram. If that beacon was generated using a random number generator, what you're going to get is a distribution on the histogram that's almost statistically flat. That's weird. Like people probably are not going to generate a statistically flat histogram from their. So that's one thing that we're going to look at. One thing we're going to investigate as well.
All right, we got Ray Davidson, PhD, extraordinaire.
Oh, now we're in trouble.
No, he's talking. Go ahead, Ray. So Ray's point on that is, so we used to tell people, if you want to get into information security, learn Nmap, learn Nessus, learn Metasploit, learn the tools to break into things. And I still think that follows. I think that that's true. So I'm going to paraphrase a little bit. I think what Ray's saying, if you want to get really good at computer security, it helps to have like an electrical engineering degree or something of that nature. So Brian, what are your degrees in, actually?
I have a couple, but I guess
Are any of them IT security related?
No, just computer science. I guess would be the closest. So my background. Yeah. So one of the degrees that I did do is in mechanical engineering, and while I was in that, I did a lot of signal processing. That's kind of what got me into that field. And so when I hopped on with John, I think it was in the first week, they were telling me some of the problems that we wanted to look at with the log stuff. And one of the things that came up was, how do we detect things occurring at regular frequencies in logs? And just instantly popped in my head, you want a frequency, fast forward transform, So that's kind of where that comes from.
You, sir, in the green hoodie. Doing fantastic. So I'm going to paraphrase your question. Something, 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 math, deviations, 95%, something, something. How did you... Kittens. So I'm going to hand it over to Joff, because I think everybody heard it. So Joff, I think you heard it. So go ahead and answer it.
I think I heard it. And I'm not sure that I can answer it. First of all, I want to point out that as we ingest the DNS data, we are able to filter it. So we try to make some intelligent decisions as to what group of data we're parsing. So we have an implicit assumption that is, it is going to be normal over time space, but only if we are ingesting the data that represents the client workstations in the network, right? So there is an implicit assumption there, but it's a very good question. And I also will say I do have a degree in mathematics, but it's a lot older and dustier than Brian's awesome degrees. So there we go.
His was just adding and subtracting. Yeah, that's right. Rocks. All right.
That's my boss right there.
All right. Any other questions? You, sir, in the orange shirt in the back. Ooh, TTL on Time to Live on DNS. Does that matter?
Yeah, good question. Yeah. Yes and no. One of the things we did start, that's a good question. We did look at DNS cache data. We dumped a cache out of domain controllers. We dumped it out of Bind9. We took a look at it from the perspective of good-bad record lookups. One of the challenges is exactly that. DNS TTLs expire and the cache is transient. So we sort of stopped looking because it really didn't turn out to be as useful as we thought. That doesn't mean we're going to stop looking forever, but yeah, it matters. Probably didn't answer your question, though. Go ahead. Yeah, I'll let John answer that one.
All right. So what type of sites have very, very short TTLs? And not just bad ones. Not just bad ones. What else? Round robin for what types of sites? Very big sites, right? So if Google has very short TTL values, we would expect that, right? We would expect that. If you have hot pick kitten love, and it's got a very short TTL value, is that strange? So yes, we haven't given up on TTLs. It's just, it's harder to go through and filter out those types of domains that we'd expect to have very, very short TTL values associated with it. Does that help answer the question? Very cool. All right. Yeah, this guy over here in the fancy hat. I like your hat, sir.
Beautiful.
Yeah. So that's a fantastic point. He basically pointed out that there's a lot of botnets out there that are actually, it looks like they're preparing for this, and they're starting to change the way that they do randomization or not, and how they actually set it up. And that's why we said it's important you look at this as a prism. It's not like one specific look. It's basically looking at it in multiple different ways. So they can change a number of their different behaviors, but odds are, once you look at it in 5, 6 different ways, there's probably going to be at least one of those that shows up as an indicator, and that's what you hunt on, and that's the goal. So great point. But if we can raise the bar and keep doing that, that's awesome. Because we haven't seen a lot of malware up until fairly recently getting all that hard to detect on the network if you're actually looking for it and you know what you're looking for. So yeah, if they continue to elevate their game, that's great. It means we're at least pushing them a little bit. So, very good question.
If I just may add just one thing to that. So in the classification feature set that I was using for the DGA detection algorithm, I went 3 gram, 4 gram, and 5 gram. It seemed to be a nice balance, and I went with the differences between the distance between them in the string. Okay. One of the other things I want to add into that feature set is that n-gram an English word or not? And to try to differentiate that out. So keep flexing the algorithm. I'm going to build multiple brains, essentially, that have different biases, and we'll try to advertise them with different biases so you have the choice of which one you want to apply. Okay? Great question. Thanks.
Gentleman in the red polo shirt. He just went Markov. You never go full Markov.
The answer is I'm really busy, and yes, it's in the pipeline for me to look at. Haven't done it yet. Yeah, would you like to write it? That's a good question. You're welcome to come work with me on that. I'd love to have somebody that's smarter than me. There's plenty of them out there. So,
That's okay.
So data analytics is not for the faint of heart. It is difficult work to do, and it takes a lot of experimentation and research, but I'd love to have help. Question? Right. So just to paraphrase that, if you go down the Markov direction, you're going to bias the model, and that's true of any of this work, actually. Even with the n-gram approach or the entropy approach or the length of the string, any one of these approaches in the classification feature set is going to bias it one direction or the other. And so I think that's the reason for us to develop multiple filters, multiple approaches, and to be very, very descriptive about them so you know what you're getting into.
Oh, no. This is Rob Vanderbrink. This is going to hurt. Rob. The question was, is there any skew because of workstation DNS cache? I believe the answer is yes, but I'll hand it over to you.
Why don't you take that one, Brian? You want me to take it? I think it's yes. I think naturally it's going to be yes, right? The cache is going to hold onto the record for TTL. It's as to whether the domain controller is going to log the record is going to be at time of lookup. I think we're going to see some skew not only from workstation cache, we're going to see it from actual DNS cache in the DNS infrastructure as well. So, a question in the back. So the question was, could you repeat the question a little louder? I didn't quite catch it. Yeah, so we don't have that module yet. The question was, have we done the modeling over DHCP networks where clients are moving around in the network? We don't have that module. That's an excellent idea, and I think it's well worth us looking at writing that one. So,
yeah, we can actually import it by host name as well. As long as that's being logged at some point, then you can. The problem is you need to make sure that they match up at that specific time whenever that log entry is created. So right now it's based on IP address, but yes, it would be relatively easy if we can pull the host name and then log that. But that would require some log filtering, but yes, you can do that. So the question was, are we looking at HTTP data? Yes. In fact, whenever you're looking at the Fourier transforms of what's leaving your environment, it doesn't care what the protocol is. Is it communicating outbound? One of the things that we're learning very, very, very cleanly right now is that traditional detection, I don't want to say is dead because it still has value, but it's very nearly dead. And the reason why is if we look at VS Agent, which is a tool that we wrote and anybody can download it, we actually created it so it's clear text HTTP and a view state parameter that's base 64 encoded with random characters in the middle of it. So it's extremely difficult to identify it because it's clear text, base 64, it's beaconing out, it's very hard to detect. But if you look at its beacon, then you can detect it a lot better. And there's all these weird protocols that are out there that are, people equip all kinds of strange protocols that malware is using today. And we want to make sure that we can continue to detect that. And that's why this beaconing analysis is so important because it doesn't care. If it's beaconing over DNS, it doesn't care. If it's FTP, it doesn't care. If it's HTTP, it doesn't care. The only thing it knows is that there's an internal connection, there's an external connection, and that connection happens at some interval. That's what we're looking at. Great question.
So the question was, would this work if I think you said proxying all the traffic and the DNS does not go outside?
Is that correct? Is that
just for clarification, you've still got an internal DNS structure though, because lookups have to be done, right? So yeah, it's going to work because the lookups are still going to be done against the internal DNS structure. It's one of the challenges we did encounter early on is to make sure some of our customers give us the right DNS sources of data. Like if they give us if you're a typical customer that's security conscious, you're going to run a split DNS, right? If you're running a split DNS and you're looking at the data that's going from your external DNS out to the root name servers or whatever, that's not the data we want, right? We want the internal client-facing DNS data because that's the one that's going to give us that distribution across all of the stations coming at it, right?
Yeah. But it's... Yeah, he's saying it's all coming back. As long as we can look at the domains, we can do domain analysis as well. So there's things that look at the domains as well. But it's kind of funny. Joff was talking about working with customers. There's a number of customers that we have. We give this presentation at IANS forums and other places, and customers are like, we want that. That looks awesome. Like, great. What we need are your connection logs from your firewall or your edge router, and we need your DNS logs. We need your web proxy logs. We don't have any of that. Okay, so we need those, but we want the tool. But the tool's not going to work without the logs, but it looks cool. So in those situations, it's just a GUI that just prints out you've been hacked over and over. I saw a hand go up here. Last question, and I think we got to wrap it up. But our booth is right outside, and yes, sir.
It's all Brian's fault.
So we're getting all these questions about weird logging infrastructures. As long as you can log internal to external connections, as long as you can log the domains that are being resolved, you can use Logstash to get it into the proper format. And I don't know where Lawrence is right now, but it looks like he's crying because he spends most of his time where customers give us strange log formats, like what you're talking about. And they say, well, we need to ingest this. And he spends a tremendous amount of time writing sed and awk scripts to get it into the format that we need to make it work. So the point is, as long as we can capture that timestamp, we can capture the internal, the external connection, as long as we can capture the domain, then yes, we can parse it and we can process it. But we need to get it into the proper format. So if you don't collect those things, this stuff isn't going to help you because we need timing and we need to know who's talking from who to what. And to be honest, all of us should have that in computer security. Okay, so I'm going to wrap this up real quick because we're at our time. So we're going to be up here. Is it okay if we hang out and answer questions for a little while? I know it's lunch, all right? So we're going to hang out. We're going to answer questions. We have free shirts out there for everybody. And they've got Popeye, free beer, yep. It's got Popeye the Sailor Man without his head because that would be copyright violation if we had his head. And he's got the Linux fork bomb tattooed on his arm, and it says, I am what I am because I RTFM. So thank you so much for coming, everybody. Get out of here.